Hello students, hope all of you are fine and are following the video lectures uploaded by us. In the previous lecture, I have given you the brief introduction about the topic which I am taking for you. That is about the conservation laws. What do you mean by conservation? Conservation means to protect, to preserve, or to maintain the things as it is. The conservation laws are the most important or fundamental ideas in physics, which states that some physical quantities of a system does not change with time. That is, they neither increase nor decrease with the time. Examples for such type of physical quantities are the mass, the total charge, the linear momentum, and the angular momentum, total energy are the few fundamental quantities which remain unchanged with the time. These conservation laws are derived from Newton's laws of motion. The Newton's laws of motion are applicable only for the macroscopic interactions. That is, in case of gravitational and Coulomb interactions, we can use the Newton's laws of motion. But these Newton's laws of motion can't be applied for strong and weak interactions. And hence we were in need of some other laws which can be applied for all types of interactions. And hence we derive the conservation laws with the help of Newton's laws of motion, so that these laws can be applied for all types of interactions like strong interactions, weak interactions, gravitational interactions, and Coulomb interactions. As you all know that Newton gave three laws of motion. The first law is called law of inertia, which states that a body or a system is not able to change its state of rest or of motion until and unless it is acted upon by an external agency or the force. Then the second law is called the law of force, which states that the rate of change of momentum is equal to the force imposed on that system. That is dP by dt equal to F. Then the third law is the law of action and reaction, which is the universal one, and we are all familiar with that. Here the notations F12 and F21 are the forces exerted by the body 1 on body 2 and the force exerted by body 2 on body 1 respectively. The magnitude of these two forces are equal but are in the opposite direction. Here the negative sign shows they are in opposite direction. While deriving the law of conservation of linear momentum, we use the terms linear momentum, elastic collision, inelastic collision, and variable mass. The term momentum is the quantity or the amount of motion associated with the moving body and is equal to the product of mass and velocity of the moving body. That is P equal to m into v. Here P and v are the vector quantities. In simple, we can define the momentum as the mass in motion. The concept of momentum is more important in situations when two or more bodies interact with each other. If the body is in translation motion, we define the linear momentum and is given by the product of mass and velocity. If the body is in angular momentum, if the body is in rotational motion, then we define the angular momentum, which is the cross product of position vector and the linear momentum vector. Then the term comes the collision. Collision is an event in which two or more bodies exert force on each other for a relatively very short time. When a collision happens, there is transformation of momentum or kinetic energy of one body to another. Usually there are two types of collisions. One is called elastic collision and another one is called inelastic collision. An elastic collision is one where the two bodies bounce apart when they collide. In elastic collision, both momentum and kinetic energy of the system or the colliding system are conserved. The examples for the colliding system are elastic collision are collision between the two billiard balls, collision between the atoms, collision of carom coins. Then the inelastic collision. An inelastic collision is one where the kinetic energy of the colliding system is not conserved, but the linear momentum of the colliding system is conserved. When the kinetic energy is not conserved, there will be a loss in the kinetic energy. That loss in the kinetic energy appears in the form of heat, sound, light, or in the deformation of the colliding system. When the inelastic collision happens, the forces associated in the inelastic collision are non-conservative forces. The most of the collisions between the macroscopic bodies are inelastic. Macroscopic bodies means the bodies which are visible to us. If the colliding bodies stick together after the collision, then the collision is said to be perfectly inelastic. Then the last term comes the variable mass. Examples for variable mass are oil tanker or the water tanker with the leakage, raindrops and rocket. These are the few examples for variable mass. In the next lecture, we shall derive the law of conservation of linear momentum with the help of Newton's laws of motion. Thank you.